my name is Nicholas, and this is my video for assessment 3. I've worked on AI, and I have created and focused on challenge as my design, and well, all of the above really, but challenge is what I try to go for in how I've created my AI. And the focus was on challenge through AI behaviors, specifically through patrolling, covering, and perception with state-based decision making. Um, this is a foundation for the game that my group's going to be making, which is going to be more of a stealth tactical game, FPS game, where they're both challenging and rewarding to implement for this type of system. So, like I said, I focused on challenge. These systems are common, these AI systems are common in FPS, but implementing them through and adding, I've tried to add more emergent gameplay into how I've done it. So, to save me some time, I've used the nav mesh. However, I've gone beyond just the basic A to B, and I've added a ton of emergent, ton of very specific scoring systems that utilize a lot of the nav mesh data. So the first thing I'll show off is the patrol system. So in stealth games, patrol routes are essential to create predictable but dynamic behavior. I implemented a patrol system using patrol anchor points. So these are my points. And these are similar to how we've made them in class, where they are A to B, but they're using the nav mesh to get the inbuilt actual paths, where the NPCs will follow these defined patrol routes, where the scoring system will also, I'll go into in a second, is a bit more dynamic than just A to B, follow 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because you see this is a tree map of points. And I'll show off, I'll just delete the player character for now. So currently you can see that there's some scoring system going on, and that the AI is scoring stuff, and then this happens. So this is my emergent gameplay where I've gone and created a guard system where there's a subtask within the guard control within the cover task, which allows the enemy or the AI, to go anywhere in the world between the current and the next patrol point, and just sit there for a while. This results in a bit of dynamic gameplay where the player will have to account for this unknown factor whilst hunting or trying to sneak past an AI. Instead of just very basic, like most stealth games, most games like Assassin's Creed, where A to B, C, D, and then stay there for 5 seconds, there, blah, blah, blah. I've tried to go beyond that and do a bit of interesting movement in the patrolling. The actual character itself, it focuses on certain places, so it either focuses on where it's moving or where its patrol point is. So you can see it's following the patrol path. But if it has no focus point, it just follows its movement itself. And also you can see that there's a cyan cone. This is what used for the perception system that I've made from scratch. It's similar to the inbuilt one, but it's a very simple system to create, or to mimic at least. And the system allows for visual and also audible sources, but I won't be able to get in time to audible. It takes a little bit of setup, and yeah. But pretty much the audible would result in getting the AI to get into a search mode where, yeah, they haven't physically seen them, but they've audibly seen, heard them, so they get polled they can be polled to be doing something in that case. So yeah, I'll show you the next task with the player, and I'll let the AI continue its normal patrolling. But until then, I'll explain its scoring a little bit. So it scores based on distance, its recency. So I also set a last time it's been to that patrol point, and also visit count. So it can't just keep going A to B, A to B, A to B constantly. And as you see, it's now starting to patrol. I'll replay that in a second, but I'll continue with the covering. With the patrolling score. With the patrol score, it is based on the distance score, so the distance from the actual point to the next. Recency, so the last time it's visited. Visit penalty, so how many times is it visited? Please don't go to the same visit point. Please don't visit the same point like 100 times before going to the next one. So you can have cycles, but this sort of stops it from going in cycles. Same as recencies, but a little bit different. and then there's backtrack. So this also stops the AI from, for example, if in this case there's two that are very similar in direction, and the AI has come from, let's say, this one here. So the AI comes there, it's now here, and it says, okay, where do I should go next? I can't go backwards, obviously, but it might go this way, yeah, and that's like a pretty much a 180. So this backtrack pretty much stops it from going in a very similar dot product backwards the way it came from. Um, and then, so yeah, in this case, it would have two children that it can go to, and it would either do A B. It would be based on distance, then recency, and then visit count. And then with the guarding system, as you saw, it took like a ton of samples around from like, let's say it was going from A to B. It would take a ton of samples between here and there, in this type of patch, and then figure out the most visible and most open. So visible means it can has line of sight to, from currently to where the guard point is. So it can't be behind a wall because that's sort of like illogical for a guard point. And then openness, where it will also poll the area around it and check if the area around it is open. So if there's no, like, how much room is there from walls. So it normally goes into an area that's open, as you should have seen earlier in the video. But I'll continue with the I mean, you'll see it again, but I'll continue with the cover system. So you saw when the cover system happened, it as you see, it sort of went for the one that's in the more in the middle area. But when the cover system goes off, it results in the AI wanting to find a ton of points. I'll pause. So you can see on the map, there's all these points, and I'm taking these from the nav mesh itself. So I'm polling the edges of the nav mesh, so it's very computationally unheavy. It's very light. Like all you need to do is reduce the number of poles, the amount of distance between each point, and how much radius it's polling the edges for, and those are all configurable. And you can see the different colors. So purple means it's direct line of sight to the player, so don't go to those type of places. Red means they are viable, but they're not the best. Orange means there are no visible peaks that the AI can do to be able to shoot the player. So even though it's covered, it's meaningless. It might as well just be hiding. So it's not actually covering and trying to shoot the player actively. So the only ones that left are the red ones, and then it chooses the green one over here with a score of 13. You can see that ones over here, the ones that are covered, but they are also the wrong direction. So here, these ones are also improved because they are physically blocking with the wall. The normal of the wall is pointing in the same direction as the AI, as the character, or closer. So that means it's actually physically blocking. Whilst here it's in the opposite direction, so it's very bad cover, even though it's technically covered by this pillar here and this other thing here. It once the player moves a little bit, it's done. Like it won't be in cover anymore, so it has to repole. But here it's in cover, it's still in cover, so it's perfectly fine. So I'll go into the specifics of that one now. I really pretty much went over it, but just a bit more in depth. So um, it collects cover points from the nav mesh. It can also do some raycasts on top of that if need be, to have a bit of emergence where it's not always just the same ones. Um, and so it finds edges, and then I go through the edges with I find the normal of the edge, and then I also split the edge into spacing. So how many like my spacing of 20 centimeters or whatever. Um, and then I add that as a candidate with a location and a normal. And then I go and score the point. So over here, after I've got the candidates, I check line of sight, so that's where it's exposed when I'm crouching, so it's purple, unreachable, but that never really happens because it should be reachable on the nav mesh. And then no valid peaks, so orange, which means it'll build the cover point peaks, where it will find 5 various ones where you can easily add more. This is very specific, very unspecific, where it just move in a horizontal path on the axis of that's perpendicular to the normal. So stand to left, right, wide to left, wide right, and then it checks line of sight to check if it's a viable peak. And then if there's no viable peaks, then orange, don't go to that one. And then the next thing is it scores the part of the the point at the end, but before that, it will score the path of. So it not only scores the points. I'm using the nav mesh to also improve the scoring. So in this score path, it's actually scoring its exposure. So how exposed is the path? So if the AI takes this path, how bad will it be for the AI to go there? Pretty much, it only currently goes based on if it has line of sight. So it goes via each point in the path, line to do a raycast. If it's exposed, add exposed weight out of the total weight, and then in the end do a fraction exposed. Um, And so then at the end, it's okay. Well, this path is very exposed. The player will assume it the entire time. Just don't go that way. So in the end, all these things together, with uh, the score point that I mentioned a bit earlier, where it scores the facing. So don't go into one that's facing the wrong way, or try not to. The distance. So there's a min max distance, nice here, and then the peak score, which is how many peaks there are out of total. And with all those together, that should result in what you have just seen. And then the next point is during the actual cover um, task, the AI not only does like the crouching and has like full autonomy, it also does the peeking. So the peeking, it crouches, and then once it gets to the peak location, it uncrouches, and then it, like tries to shoot the player. And you can see also that the perception system is also working by saying that the character is currently not visible by a very basic raycast just to show debugging. And you can see that the AI is choosing different parts of the current parts of the cover that were calculated to be peaks. And then if I move the player towards um, the AI, you see it's tracking the guy. But if I go and make the AI exposed, you'll see that the AI will quickly try to relocate, and it will find right there then the best next path, and it relocates because it was not the best and it was still exposed a little bit. So it's going, okay, actually I want to go here. So it's now gone there, and yeah, it continues its movement. Um, and the whole state machine is controlled by so there's multiple components: the perception component, subsystem which controls the perceived sounds that gets pulled into the component. Then there's all these tasks are controlled by nav tasks, where they have on start, on tick, and on cancel. And this one's much more of a complex one, the couple one. So it has within its own task, it has subtasks. So it has its phases inside of it. So it has phases of move, hold, and peek. Same as patrolling, whereas patrolling has move and guard, and then other ones, for example, flee and advance, only have one. It's very much more simple. So it allows for more complex and more simple. And then these will get held within the navigation component, which have all the configs which the tasks point to, and then allows for an API to start tasks and cancel active tasks and stuff like that. And then this all gets the way that I'm actually controlling the AI with the crouching, the focal points, the also they have like walk speeds and etc. There's a few other things like that. This is all based on the enemy AI controller. Um, there are systems that I have not fully finished yet, which is like a squad system for AIs to communicate, but that's not I can't show that. There's nothing there for it yet. Um, and you can see that there's a few extra little components. So the, through Unreal, there are no such thing as here's a path, now use it. There's only move towards a location or move towards a like actor. But what if I already had a path with me? I just have a bit of an API that allows me to use a already calculated nav path, and so I don't need to recalculate the nav path, even though I already have one in some cases. And then over here, target found, target updated, and target lost, which is the perception system working where if it's now found the target after it's not been perceived, either through audible and visual, and then if it's updated, so it already has been perceived and has been updating. So here, update the object or the struct, and then here, if it's lost, okay, it's lost it, and in each case, it tries to get the best target. So this is already compatible with multi-target systems. So it will target the best target it can. So it just tries to get the best target from, and then also that polls the try to get best target in total, where it gets the scoring of the target based on its perception. So if it's perceived, visible, and audible, the scoring of that. If it's perceived at all, just stop. Then its distance, and then like its alignment and things like that. Yeah, like towards the front of the front of the AI. So what's currently in front of the AI, and then like also distance based. So that pretty much is everything. These systems I've made is just a standard to standardize the AI system. It's very utilitarian, but also challenging in its own right. And I think you can easily add tons of color systems towards it. It's very much more replicatable.